If all the elements of set A are the elements of set B, then A is called the subset of B and it is denoted as A is the subset of B. If A and B are any two sets, if A is a subset of B and A is not equal to B, then A is called the proper subset of B. So the collection of all subsets of A is called as the power set of A. Consider for example a set 1, 2. Hello dear students, welcome to this session of Mathematical and Statistical Computing. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. So, in my previous class, we have discussed regarding the definition and types of sets. Today in this session, I am going to discuss regarding the operations on sets and the problems related to operations on set. Now, let us discuss regarding first the subsets. What is a subset? So, a set A is said to be a subset of a set B if every element of A is also an element of set B. If all the elements of set A are the elements of set B, then A is called the subset of B and it is denoted as A is the subset of B. If A belongs to A implies A also belongs to B. For example, the set of rational numbers is a subset of the set of real numbers. So denoted as Q is a subset of R. The set of rational number is a subset of real numbers. All the elements of Q must be the elements of set R. Now let us take another example. If A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4, 5, 6, then A is called the subset of B because A contains 1, 2, 3. They are also the elements of the set B. That means all the elements of A must be the elements of set B. Therefore, A is the subset of B. If I take one more element, let us take for example C. C is equal to 2, 3. Then this C is also the subset of B because C contains 2 and 3 which is also in the set B. Therefore, C is the subset of B. Right. If all the elements of A must be the elements of set B, then A is called the subset of B. Now, next one is a proper subset. What is a proper subset? Proper subset and a superset. So, let A and B are any two sets. If A is a subset of B and A is not equal to B, then A is called the proper subset of B and B is called the superset of A. If A is the subset of B and A is not equal to B, then A is called the proper subset of B and B is called the superset of A. B is called the superset of A. Now let us consider for example, if A is equal to 1, 2, 3. 1, 2, 3 is a proper subset of B. What is B? B contains 1, 2, 3, 4. If all the elements of A are the elements of the set B, then A is the subset of B because A contains 1, 2, 3 which are the elements of the set B 1, 2, 3, 4. That is, therefore A is called the proper subset of B. So, if A and B are any two sets, if A is a subset of B and A is not equal to B, then A is called the proper subset of B. This is an example for a proper subset. Move on to the next concept, the intervals of a set. So, here we are going to study regarding intervals, closed interval, open interval, semi-closed and semi-open, that is up closed and up open interval. So, open interval and open interval is denoted by like this small bracket, that is A comma B, is all the points between A and B, but A and B themselves do not belong to this interval and it is denoted as A comma B is equal to X such that A less than X less than B. All the values which lies between A and B is called the open interval. Suppose here this is A and this is B. Here this is A and B. All the values which lies in between A and B is called a open interval, that is A comma B. That is A less than X less than B is called an open interval. So A comma B is equal to X such that A less than X less than B. All the values which lies between A and B comes under open interval. So for example, minus 3 comma 5. Minus 3 comma minus 5 means minus 2, minus 1, 0, 1, 2, 3 and 4. The values which lies between minus 3 and 5. So minus 3 comma 5 means minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and 5. So only these values comes under the open interval, that is minus 2, minus 1, 0, 1, 2, 3 and 4. In between minus 3 and 5 is the open interval for this minus 3 comma 5. Similarly, for 2 comma 7. So 2 comma 7 means that is 2, 3, 4, 5, 6, 7. So in between 2 and 3 is this. 3, 4, 5 and 6 comes under the open interval 2 comma 7. Okay. Now move on to the next one is closed interval. So the closed interval is denoted by a big bracket a comma b. So the interval which contains the endpoints also is called the closed interval. All the values which lies between a and b, including a and b, is called the closed interval. That is, thus the closed interval of a comma b is nothing but x such that a less than or equal to x less than or equal to b. That means all the values of x which lies between a and b, including a and b, is nothing but the closed interval. Let us consider, for example, minus 2 comma 2. So minus 2 comma 2, all the values in between minus 2 comma 2, including minus 2 and 2, is minus 2, minus 1, 0, 1 and 2. So for example, another example, 3 comma 8 means 3, 4, 5, 6, 7 and 8. So if it is like this, this is called a semi-closed and semi-open interval, of closed and of open interval. A comma b, that means all the values of x which lies between a and b, including a less than or equal to x less than b, is an interval from a to b, including a but excluding b. Similarly, a comma b, here x such that a less than x less than or equal to b is an interval from a to b, including b but excluding a. All the values which lies between a and b, including a, that is of closed and open. Here it is of open and of closed, that is all the values between a and b excluding a, including b, is called the of closed and of open. For example, let us consider, for example, two comma 6. Suppose if I write this 2 comma 6 like this. Okay. So here this is all the values which lies between 2 and 2, 3, 4 and 5. That's it. Okay. Whereas here, so all the values from 3, 4, 5, 6, including 6. So here 2 is included, 6 is excluded. Here 2 is excluded, 6 is included. That is semi-closed and semi-open intervals. Now move on to the next concept. This is very important concept, that is power set. Power set means the collection of all subsets. The collection of all subset of a set A is called the power set. So the collection of all subsets of A is called as the power set of A. Consider, for example, a set 1 comma 2. Now let us write down the subsets of 1 comma 2. So the subsets of 1 comma 2 are 1 comma 2, or null set is a subset 1, 2 and the entire set 1 comma 2. So therefore the subsets of 1 comma 2 is, first let us take null set, then element 1, element 2 and 1 comma 2. So these are the subsets, null set 1, 2 and 1 comma 2. So all the subsets of the set A is called the power set. The set of all these subsets is called the power set of 1 comma 2 and it is denoted as P of A is equal to null set 1, 2 and 1 comma 2. Suppose if a set A contains n elements, the number of elements in a set A is n, then the number of power set P of A is always of the form 2 to the power of n. Since this contains 2 elements, n is equal to 2, therefore here the number of subsets is 2 square, 2 square is equal to 4. 1, 2, 3, 4. 4 subsets. Okay. Now, write down all the subsets of the following sets. So, this is a 2-marker question. You may expect this type of question for 2 marks. Write down all the subsets of the following set. First one, A comma B. The subset, that is called the power set. So, here first one is a null set, then element 1, then element 2 and 1 comma 2. These are the subsets. Similarly, for the second one, the all subsets, that is the power set, first a null set, then set 1, then 2, then 3, then 1 comma 2, then 2 comma 3, then 1 comma 3 and 1, 2, 3. So this is called the subset. That is, just count how many are there. So this contains n is equal to 3 elements, 2 cube. 2 cube is equal to 8. 1, 2, 3, 4, 5, 6, 7, 8 subsets. Okay. These are called the subset for the given problem 1, 2 and 3 are A, B. Now, universal set. Next one is the universal set. The basic set which contains all the elements of a problem under consideration is called an universal set and it is denoted as U. The set which contains all the elements which are under consideration is called an universal set. So that is the basic set which contains all the elements of a problem under consideration is called an universal set. Now the next concept is the Venn diagrams. This is very important. How to represent the given set in a diagrammatic form. So that is called a Venn diagram. Most of the relationship between the sets can be represented by means of a diagram known as Venn diagram. So the relationship between the sets can be represented by means of a diagram known as Venn diagram. The universal set represented usually by a rectangle and a subset. So the universal set is represented by a rectangle, and whereas the subsets are represented by the circles, right? So in Venn diagram, the universal set is represented by a rectangle, whereas the subsets are represented by the circles. That is, the universal set represented usually by a rectangle and the subsets are represented by the circles. Now let us take an example. For example, let U is equal to universal set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the universal set, and A is equal to 1, 3, 5, 7, 9 is a subset. So universal set contains all the elements 0, 1, 2, 3, 4, 5, 6 up to 10, in which the subset is nothing but A, which contains 1, 3, 5, 7, 9. So all the elements are represented, all the elements of the union set is represented in this rectangle, and the subset of that is denoted in the circle, that is 1, 3, 5, 7 and 9, right? So here this A is the subset of the universal set. Now next, let us know regarding union of sets. So operations on set, that is union of set. Let A and B any two sets, then the union of A and B is the set which contains all the elements of A and all the elements of B. A set which contains all the elements of A and B is called the universal set, and symbolically it is denoted as U. That is A union B. A union B is a set X such that X belongs to A or X belongs to B. Let me take an example, a small example. If A is equal to, a set A contains 1, 2. Another set B contains 2, 3, 4. Then the union of these two sets is A union B is equal to, first write down A. A contains 1, 2 and elements of the set B, already 2 is included. Then we can take 3, 4. So this is called A union B. That is X such that X belongs to A or X belongs to B. That means all the elements, the set which contains all the elements of A and B, set of all the elements of A and B is called the union of two sets, denoted as A union B. Now let us discuss one more example. If A is equal to 2, 4, 6, 8, B is equal to 6, 8, 10, 12, then A union of B. A union B is equal to, first write down 2, 4, 6, 8, 10 and 12. These are the elements of A union B. So A contains 2, 4, again B contains 6, 8, 10, 12. This is A union B. Few properties regarding union of sets. Union of set A and its subset B is the set A itself. Union of a set A and its subset B is set A itself. That is, if B is the subset of A, then A union B is equal to A. If B is the subset of A union B is equal to the same set we will get. The union of two sets can be represented by a Venn diagram like this. So this is called the union of two sets. Union of two sets is represented in a Venn diagram like this. So say, let us take for example, if A is equal to 1, 2, 3, another set B is equal to 2, 3, 4, 5, 6. Then union of this is denoted as A union B is equal to the set 1, 2, again 3, 4 and 5. So here what is A contains? A contains 1, 2, 3 and B contains 2, 3, 4, 5, 6. So this is called the union. So this part will give the common elements in both the sets A and B. So A contains 1, 2, 3. B contains 2, 3, 4, 5, 6. This is called A union B. A union B. All the elements 1, 2, 3, 4, 5, 6. Now move on to the next. Some important properties of union of sets. A union B is also equal to B union A. That is, union is a commutative. Commutative law is satisfied. A union B is equal to B union A. And associative law, A union B union C is also equal to A union B union C. A union B union C is equal to A union B union C, associative law. Then law of identity, that is identity element. A union null set is equal to A. That is called law of identity. Here null set, this is an identity element of U. So A union A is always equal to A itself. That is demopotent law. U union A, any set and the universal set, union of any set and the universal set is equal to the universal set itself. That is called the law of U. That is commutative law, A union B is equal to B union A. Associative law, A union B union C is equal to A union B union C. And the law of identity, if any set and the union of a null set is equal to the same set, and a set and the union of a set, that is equal to the same set you will get, that is called demopotent law. Any set and the union of an universal set, it is a universal set itself. Now move on to the next. The operation is intersection of sets. Intersection. So the intersection of two sets A and B is the set of all those elements which belongs to both A and B. That is the common element. The elements which belongs to both A and B is called the intersection, common element. So symbolically it is denoted as intersection, reverse U. And it is denoted like this: A intersection B is nothing but X, such that X belongs to A and X belongs to B. Now let us take for example, if A is equal to A, B, C, D. A, B, C, D. Another example, B is equal to C, D, E, F. Then the intersection of these two is denoted as A intersection B is equal to the common element. So A is not in the set B. B is also not in the set. We have C. So you can take C and D. C and D are the common elements. So therefore, the intersection of A and B is C, D. That's it. Right. Let us take one more example. Let A is equal to 2, 4, 6, 8, B is equal to 6, 8, 10, 12. Then A intersection B. What is A intersection B? The common in both A and B. So 2 is not here, 4 is not there, 6 and 8 are the common elements. 6, 8 is the intersection of A and B, the common elements. So how to represent this in a Venn diagram? So this can be represented in a Venn diagram like this. So all the elements of A contains 2, 4, 6, 8, B contains 6, 8, 10, 12. So this is called the intersection, A intersection B. Okay, this common element, 6 and 8 are the common element, that is the intersection of A and B. If A and B are two sets such that if the intersection of two sets is a null set, then A and B are said to be a disjoint set. If the intersection of two sets is a null set, let us take for example, if A is equal to 1, 2, 3, another set B is equal to 4, 5, 6, then the intersection of these two sets, so no element is common here, the intersection is a null set, therefore A and B are disjoint set. That is, if A and B are any two sets such that the intersection is a null set, then A and B are called disjoint sets. Now move on to the example, one more example. Let A is equal to 2, 4, 6, 8, B is equal to 1, 3, 5, 7. Find whether A intersection B are disjoint or not. A intersection B, the common element. What are the common element? Here 2 is not there, 4 is also not there. So then 6, nothing is there. So that is, it's a null set. That means A and B are disjoint sets. Let us know regarding difference of two sets. Difference of two sets. The difference of set A and B is the set of element which belongs to A but not B. All the elements which belongs to A but not belongs to B is denoted as A minus B, A difference B. Symbolically, we are going to represent it as A minus B and it as A minus B. That is, A minus B is nothing but X such that X belongs to A and X does not belongs to B. Now, let us discuss with a simple example. If A is equal to 1, 2, 3, 4. Another set B is equal to 4, 5, 6, 7. Then what is A minus B? A minus B means all the elements which are in A but not in B. In A we have 1 is not included in the set B. Similarly 2 and 3. 4 is there, we don't want. This is called A minus B. Elements which are in A but not in B. On the other hand, similarly, if you want to write B minus A. B minus A means elements which are in B but not in A. So in B we have 4, we don't want. Then what is left over is 5, 6 and 7. B minus A. Elements which are in A is called A minus B and elements which are in B but not in A is called B minus A. That is called the difference of two sets. Now one more example. That A is equal to 1, 2, 3, 4, 5, 6. B is equal to 2, 4, 6, 8. Then find A minus B and B minus A. Now what is A minus B? A minus B means elements which are in A but not in B. In A we have 1. So 2 we don't want, 3, then 4 is there, 5, that's it. So A minus B contains 1, then 3 and 5. B minus A, elements which are in B but not in A. So in B we have 2, here it is 2, 4 is also there, then 6 is also there except 8. 8 is only the elements which is not in A. That is B minus A is 8, A minus B is 1, 3, 5. Hope you got an idea. Now, move on to the one more example. If let B is equal to A, E, I, O, U and B is equal to A, I, K, U, then find B minus B. B minus B, all the elements which are in B. A is there, we don't want. E is not here, E, I is here, O, then U, that's it. Only E comma O. So A is there, E is not here in set B, I is also included, O is not there, U is there. Now what is B minus E? B minus B. B minus B means elements which are in B but not in. So A is there, I is also there, K is not in A, that is not in B, then U is there. So only one element, that is K, right? Now, move on to the next example. If X is equal to A, B, C, D, Y is equal to F, D, G, F, find X minus Y. So, X minus Y means all the elements which are in X but not in Y. So, A, B is there, C is not here and D is there. So, X minus Y is A comma C. So, X minus Y is equal to A comma C. Second one, Y minus X. Y minus X means all the elements which are in Y but not in X. F is not in first set, F, B is also there, then D is also there, G is not there. F comma G. Now the third one, what is third one? This is X intersection Y. Intersection is nothing but the common. What is the common in these two? A is not common, B is a common element, then C is not there, D is also the common element. B comma D is the common. The intersection is B comma D. So X minus Y is A comma C, Y minus X is F comma G and intersection of these two is B and D. Hope you followed. So these are few types of problems based on the operations on sets like union, intersection and the difference of the sets. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.